Okay. And we're going to talk about how you would graph y equals 2 times the cosine of pi over 2x, and it says do it over 1 period. So talk to me about what you would want to do first.
Figure out the x-axis.
I think we do need to figure out our scale for the x-axis, because do you see we've got some sort of change in period? Yeah, and this one's a little funny looking because it's not just a number in front of x, it's what? Well, it is a number, but it's an irrational number. It involves pi. So my period, I find it by doing what?
2 pi.
2 pi over whatever the b is. And in this case, b is what? Pi over 2. Now that looks funny when I've got a fraction over a fraction. So let's write it this way. 2 pi divided by pi over 2, which means I can multiply by the reciprocal, and that's 2 pi times 2 over pi. What happens to my pi's? And that means my period is just what? Okay, and that's okay. That's going to mean 1 complete cycle, 1 period, will end at 4. So what's going to be halfway between? 2. And then this would be 1, and this would be 3. Everybody good with that? So my angle measures look a little funny, but they're just, it's in radians. Okay, it's fine. Do I have any change in amplitude?
Yes.
What is it?
2.
All right, so my amplitude is 2. That means that my y values have to go up at least to +2 and down to -2. Now, because it's a cosine function, what is it that you would think of for graphing? Hala. And since I already have this marked off, I mean, I'm going to have 0, 1, 2, 3, 4 for my angles. My ratio normally for Hala would start where? At 1, then 0, then 0, and back to 1. So since I have an amplitude of 2, that means I multiply this row by 2, and I'm going to have 2, 0, -2, 0, +2. Does that make sense? All right. So what if I get somebody to come up here and you show me how you would graph this? Volunteer? Oh, come on down. We did this the other day. All right. So we did get these points on here, got this graph sketched, and that's 1 period of this cosine curve. All right. Now, this is asking us to come up with the equation that would fit this particular graph. And notice it says it could be a cosine or it could be a sine. Now, how am I going to figure out which one this is? Based on what we know right now.
Starts at the 0 mark.
All right, very good. The fact that when the angle is 0, the ratio is 0, that looks like a sine, right? Because if it was cosine, it would be like the one we just did, and it would start off high. So I'm pretty sure this is going to have to be y equals, and it's going to be the sine of something. Now, do you think we have any change in amplitude? What is it? 1/2. And I know that because it hits a high point of 1/2 and it hits a low point of -1/2. The problem is I got to figure out if I've got any kind of change in the period. And once I know that, I'm done. So a normal period for the sine curve is how much? 2 pi. That's one complete cycle. What do you notice we have here? One complete period ends where? At pi. So you're exactly right, Josh. If I look for 2 pi radians, I have 2 full cycles, right? So guess what my period is? 2x. You're right. I get 2 cycles in what would normally be 1 full period. That's one way you can look at it and come up with it. Does that make sense? Okay. You guys got it. And then you can double check yourself if you wanted to by going back and doing 2 pi divided by 2 gives me pi for 1 period. Okay, but that's it. That's how you're going to get the equation.
Does the 2 times have to be like parentheses or anything like that? Because on my MATLAB, it kind of like, it counted one way, it's wrong because it wasn't in parentheses.
I'm glad you brought that up. It would be preferred, let's put it this way, to put your argument, whatever that angle measure is, in a parentheses. I was not aware my MATLAB was counting it wrong because it's kind of interesting in that they sometimes don't do it themselves in the notes, but that would always be a good idea so it's clear this entire thing is your argument, is your angle measure, okay? All right, now, any other questions? Are we good? All right, here's the last thing in 6.3. And this is kind of a play with your calculator type of question in a sense. They've given us a function that approximates the average temperature in Phoenix, Arizona. Now, think about that for a minute. X is the month, and X equals 1 corresponds to January, X equals 2 to February, and so on. Does that sound like a sine curve might be a good tool for approximating average temperatures? Because if you think about it, what tends to happen in, say, January? Are your average temperatures going to be high or low? Probably going to be low. And then as you go into spring, will the average temperature go up a little bit? Get summer?
It's a cosine curve.
It's what?
It's a cosine curve because it starts low, right?
If January is absolutely the coldest month, then yes, it would. But now keep in mind, yeah, well, but let me show you something too. We haven't gotten to this part yet. This is kind of pre-teaching because we're going to talk about this in a little bit. Notice this has something we haven't seen before. It's got a plus 74 at the end. It's also got X minus 4.3 in the parentheses where there's something that's happening to the X before it gets multiplied by the pi over 6. Now, I'm not going to ask you to graph this thing by hand the way we've been doing this. This is going to give us an idea of how we can find some information from a graph, and then we're going to understand in a little bit what all of the extra things we see actually mean. If we add something to the end, if we make some sort of change to the X. Because so far all we've talked about is change in amplitude or change in period. But there are other things that could change. So this is actually shifting things a little bit as far as making it come up or making it move to the right or the left. Now, we could see what this graph looks like in the calculator. I'm going to go ahead and put it in so you can see it. And I need to be sure that this is in radians, so let me double check that. It is. And I'm going to type in 19 times the sine of, and my angle will be pi over 6. And then in another parentheses, I'm going to put X minus 4.3. And close that off, and then I'll add the 74. I'm going to set my window the way they suggested, where it'll go from 0 to 25, and then from 0 to 125. Now, let me just kind of explain to you what this window is doing. The X is the month. So this is going to be 25 months that will be shown. So it's a little over 2-year period. Okay. This represents the output, which is going to be the temperature. So it can go down to 0 degrees and up to 125. I don't want to move to Phoenix. I don't know about you. Okay. So let's look at the graph and see what it does. Right now, nothing.
I think you didn't type it in the y equals.
Where did I type it? I thought I did.
No, it was just
Oh my goodness. Well, thank you. I appreciate, I don't know why I didn't put it in there, so let's fix it. Okay, pi divided by 6. And then we have the x minus 4.3 and the plus 74. Okay, now let's see. There we go. Oh my goodness. That's, I did what?
You put times 4.3. You didn't put minus 4.3.
I'm having a rough day today. It started off where I locked myself out of my office. And it's just getting better. What can I say? Now, oh, okay, that's better. I was going to say, man, there's a lot of change going on in Phoenix. Okay, that looks more logical, does it not? All right, so you have your average temperature showing up here, and we could pick any one. If we wanted to do trace, we could find out at any point in time what the average temperature was for that particular month. Okay, now, according to this model, could you tell me what would be the average temperature during the month of October? All right, so if we are letting x equal 1 correspond to January, then where would October be? At 10. So here's, we can move. The only thing is, notice my x's, they're not necessarily stopping at exact integer values. So let me show you. Yeah. Yours is different? Okay. 19 times.
Well, what did you want to wonder? I put 0 and 125.
0 to 25 on your x scale and 0 to 125 on your y. Okay. Let me check my y equals again. We had 19 times the sine of pi over 6, x minus 4.3 plus 74. Did you make sure you had closed off all the parentheses before the plus 74? I have 2 sets of parentheses. Okay. Because I'm pretty sure that's what we need. So let me just show you, if you want to get October, instead of just hitting trace, if you'll hit second trace and you hit enter for value, I can tell it, I want to know what the temperature is when x is 10. So if I round that to the nearest degree, what do I get? 77 degrees. Are y'all getting something different?
I got it. I don't know what I did.
Okay, but you've got it now?
Before I did the pi over 6, I put 2 parentheses and 1.
Ah,
So
okay. So you figured it out. All right, and then the last question says, what would be an approximation for the average annual temperature in Phoenix? Now, how would I get an average annual temperature?
Take the 2 years in the body, or Adam and plug.
Do I want to do the 2 years? Or, this thing is pretty much bouncing back and forth evenly between a high and a low. So what might be a good way to get the average?
About 2.
I didn't do it.
If you take the minimum, the lowest monthly temperature and the highest monthly temperature, and you get the average of those, that should be my average temperature for the year. So let's see if we can figure out what the minimum would be and what the maximum would be. So there are ways, let's see, if I do second trace to get a minimum, okay, I'm blinking and I'm to the left of this point. So if I hit enter, Now I can arrow to the right of that point, anywhere on the right side, hit enter, and if I hit enter a third time, that's got a minimum of what? 55 degrees, okay? Did you notice that if we go back to second trace, there was a place that would let me find the maximum? We could do the same thing there. So this time, I want to be to the left of the high point, and I'm going to hit enter. And then I'll go to the right of the high point. By the way, you won't have to do this on a test. I'm just kind of showing you how you could use the graph to help you out. If I hit enter for the third time, look at that. That's going to be a max of what? 93. So if I were to come up with the annual average, I would want to take 55 plus 93 divided by 2, and that's going to be about what? 74 degrees. Now, if this was not as balanced a curve as it is, I would not take the low temperature and the high temperature and add them together, because if it spends more time up at the high and just a little bit at the low, but since this is that nice smooth sine curve that's very balanced, that would be the easiest way to find it. Okay, so that's just a quick application thing. You will not have one like that on the test. All right, 6-4. Translations. I know, we're finally moving into a new section. It took a while to get through 3. So, horizontal translations are the first ones we're going to talk about. And we saw that in that equation you just looked at. Here's where they show up. In the parentheses with the x, okay? It's not stuck at the end after you've done everything else. It has nothing to do with period. It has nothing to do with amplitude. But if I have x plus something in parentheses, so that means my angle measure is getting shifted, or x minus something in parentheses, that tells me I am moving horizontally. Okay, that is going to be a horizontal translation compared to the original graph. Now, this is the part that's a little bit sneaky. Horizontal translations are always the opposite of what you would expect. Let me give you a quick example.
Great. It's perfect.
Josh is excited. We're on to something that works for you. Okay, so y equals x squared. We'll just stick with a parabola because we know pretty comfortably what a parabola should look like. Now, if in a parentheses I put x minus 3 and then I square that before I hit graph, I just want you guys to tell me, you know y equals x squared is going to look like this, right? So if the only change is I'm going to subtract 3 from x before I square it, what's it going to do to my graph? Okay, we know it's got to move 3, but which way do you think it's going to go? All right, I heard some left, I heard some right. I've already told you it's horizontal, so hopefully nobody's thinking up or down. It's either got to move 3 to the left or 3 to the right. Let me see hands. How many of you say it's going to move 3 to the left? How many of you say it's going to move 3 to the right? Oh my goodness. Okay, so I am preaching to the choir here because you guys clearly know what happens. There's the original, and yes, it moves 3 to the right. And the reason is you think opposite whenever it is a horizontal translation. Okay? So we're going to be moving d units to the right if whatever shows up after the minus sign is positive. In other words, if I see x minus a number, I'm going to the right. If I see x plus a number, then I'm going to the left. And the way I get x plus a number is it would be x minus a negative, okay? It's much easier to just look at this, and it's going to be the opposite of the sign you see. So if we want to graph this over one period, now look at the equation and tell me, do you see any change in amplitude? Do you see any change in period? Do you see a horizontal translation? So it's going to shift which way? All right, this tells me I'm going to the left 3 pi over 4 units. Okay, now here's one way that you can figure out, because remember, we've got to be able to mark on our axis where are all of these key points we need for high point, low point axis, right? So this is probably the easiest way to find it. Take whatever is in this parentheses, and a normal period goes from where to where? 0 to 2 pi. What I want to do is figure out if I put x plus 3 pi over 4, kind of sandwich it between, this is going to let me solve to figure out where should this start and where should it stop. Okay, now you may be able to do that a different way, but especially if we get some other stuff going on, you might find this is helpful. All I need to do is get x by itself in the middle. And the problem is right now it's got a 3 pi over 4 being added to it. So how do I get rid of it? I need to subtract it. But if this is a compound inequality, because I have more than one inequality statement here, I don't just subtract 3 pi over 4 from the middle. I also have to do what? I have to do it on either side of that inequality. If it's an equation, what I do to one side, I have to do to the other. Same concept here, but I don't just have one inequality sign, I have two. So I've got to subtract 3 pi over 4 on the left and on the right so that I can see where all these values get sandwiched between. Now, 0 minus 3 pi over 4 means I get a negative 3 pi over 4, and that one you probably could have figured out on your own. If I want to move to the left 3 pi over 4, then definitely I'm going to be starting at negative 3 pi over 4. Now, I got to figure out where this thing ends on the right. So what is 2 pi minus 3 pi over 4 going to be? This is where you got to make sure you keep up with your rules for fractions. If I'm going to be adding if I'm going to add a fraction to something, I got to have a common denominator. So how do you write 2 pi as a fraction that has 4 in the denominator? Yeah, multiply by 4 over 4, and that means I've got 8 pi over 4, and I'm subtracting 3 pi over 4 from it. Where does that mean I end? What is 5 pi over 4? Does that make sense? Okay. Now, I need to put these units on this scale because it just said 1 period. And this is going to mean that adding these together to find those midpoints will be very helpful in knowing how to mark this. So I'm going to get an endpoint at negative 3 pi over 4 and one at 5 pi over 4. Let's add these together and then divide by 2. All right, so 5 pi over 4 plus negative 3 pi over 4 is what? And 2 pi over 4 divided by 2 is the same thing as multiplying by 1 over 2. 2's are going to cancel. So that means we're also going to need to have a mark where the midpoint between a negative 3 pi over 4 and a positive 5 pi over 4 is going to be pi over 4, right? So far, you guys with me? No?
Where'd you get the 1?
Remember, to get the midpoint, you add the 2 together and divide by 2. So when I'm dividing by 2, that's the same thing as multiplying by the reciprocal, which is 1/2. Okay? All right. Can you figure out which point would be halfway between negative 3 pi over 4 and positive pi over 4? Did I hear a yes? Can somebody tell me how? What did we just do to find this midpoint? We added these together and divided by 2. Can you add these two together and divide by 2? That'll tell us where we need to have another crossing point. You found it yet? Negative 3 pi over 4 plus pi over 4 is how much? Negative 3 pi plus 1 pi is negative 2 pi over 4. And instead of dividing by 2, you multiplied by 1/2. What did you get? Am I losing you guys?
Pi over 4.
Yeah, the 2's cancel. That's a negative pi over 4, right? Okay, and I've gotten off on my scale. So let's see. Let's just turn this into the negative pi over 4, and I'm going to extend this out a little bit and make it negative 3 pi over 4 here so that I'm a little bit more balanced, okay? And then I've got to find the midpoint between these two. So how do I do that? Add the two together and either divide by 2 or multiply by 1/2. See if you can tell me what would be halfway between these. I'm sorry I didn't get this that balanced. 3 pi over what? How many of you think it's 3 pi over 4? Perfect, that's exactly right. If I add pi over 4 plus 5 pi over 4, that's 6 pi over 4. And 6 pi over 4 times 1/2 turns into 3 pi over 4. Okay, and you said there's no change in amplitude. There was no shift in or change in the period. We only had the shift that was horizontal. So I want somebody to come graph this. Okay, so that's how we got it graphed. Thank you, Elizabeth. Now, let's see what happens here, and can we figure out what kind of transformations we may have? Do you notice any change in amplitude?
Yes.
So we're going to have to pay attention to that. That's a change in amplitude. Do you notice any change in period?
No.
No, but what else do we have? A translation going which way?
To the right.
Good. This is moving to the right, pi over 3 units. Now, ideas. How do we want to start this? We can definitely mark off amplitude. We know we're going to go to a high of +2 to a low of -2, right? All right, what else do I need to find now? What did we do last time when we had that horizontal translation? Do you remember what we did with what's in the parentheses? We sandwiched it where? Yes, between 0 and 2 pi. So let's start off doing that. If I were to put x minus pi over 3 between 0 and 2 pi, this will tell me where the period starts, where it ends. So what do I have to do to both sides? Add the pi over 3. And actually I'm adding it in 3 places because I'm adding it in the center so that I end up with just x. Got to add it on the left of the first inequality, on the right of the second. So this thing's got to start at pi over 3. Where will it end? And give it to me as an improper fraction. What would 2 pi plus another pi over 3 be? You got it, guys? 2 pi plus another pi over 3 is 7 pi over 3. Now, does everybody understand how to get that? All right, you got to change. Let me show you up here. If I have 2 pi over 1 plus pi over 3, I got to get a common denominator. It's got to be what? 3. So if I multiply this by 3 over 3, that's how it would turn into 6 pi over 3 plus another pi over 3, which is how we get 7 pi over 3. All right, so here's what I know. This thing is going to start at pi over 3 and it's going to end at 7 pi over 3. Now, how am I going to figure out what all these other values are? Add them together and divide by 2. All right, I want you guys to see if you can tell me where this is. So pi over 3 plus 7 pi over 3 is 8 pi over 3. What is 8 pi over 3 times 1/2? Good. 2 goes into 8 4 times. That means this is 4 pi over 3. So far, are we all right? Okay. Can you figure out where this is? What would be the value on that one? At least we don't have any negatives we're working with here. These are all positives. So what would be this value between pi over 3 and 4 pi over 3? Anybody found it? Yeah, Jason? Say it again.
5 pi over 6.
You all agree with Josh? He is exactly right. 5 pi over 6. If I add pi over 3 plus 4 pi over 3, that's 5 pi over 3. I multiply that times 1/2. That's how we got 5 pi over 6. Okay, we're going to do the same thing here. So if I add these up, I get 11 pi over 3, and you got to multiply that times 1/2. And that turns into 11 pi over 6. Okay, you guys give me a quick signal. How comfortable are we with being able to figure out these values on the x-axis when we have a horizontal translation? Are you here, here, or here? Okay, I'm seeing a lot of thumbs up, so that's good. Then we're just continuing to find, once we get the endpoints, we just continue to find midpoints. All right, what would you do now in order to start graphing this? Since it's a cosine curve, I probably should think of what? Hala. So if I write out hala, okay, normally your high point is what? Axis is 0, low is -1, axis is 0, high is 1. But we had an amplitude change of what? A -2. So if I multiply all of these values by a -2, my high point's now where? Yeah, it's going to turn into the low because it's going to become a -2. 0 times anything is 0. A -2 times a -1 is +2. I get 0 here. And -2 times 1 is -2. So these are the values that we have. We start at pi over 3. Go to 5 pi over 6, 4 pi over 3, 11 pi over 6, 7 pi over 3. You don't necessarily have to put these on here, but this is going to be my angle. This is going to be my ratio. And I need this and this to get it graphed. Right? Okay. Way that I could explain it to you that has a few more steps. All right. Look at this thing. Tell me what kind of transformations you see here. What's one change?
Amplitude.
Amplitude. What's my amplitude? 3 over 2. What else do you see? I have a period change. How do you know that? Where does that show up?
It's in front of the
And it's 2 that's in front of the x. So I've got to adjust my period. And what else? I've got a translation that's horizontal, right? Because there's a minus pi after that 2x. So talk to me then about what you think we might need to do. And I will kind of explain there is a little bit of a shortcut on this, because before, when we didn't have a horizontal translation, we just figured out what the period was and we were able to make all the adjustments. Do you think if we do what we did on these others and we just take what's in this parentheses between 0 and 2 pi, it'll kind of take care of both things at the same time? It'll fix the period and give us the start point and the end point? It actually will, because after you add pi to each side, then you're going to have to do what? Divide by 2. And isn't that what we do when we're adjusting the period? We take 2 pi and we divide it by whatever that b value is. So we're still going to be dividing by the b value. It just lets us do it all in one step. So it's really not any extra work. We just have to be a little bit more careful when we set this up. So we're going to go from 0 to 2 pi, and we'll put 2x minus pi in between. Okay, now carefully tell me, how are we going to get to where the only thing in between those inequalities is x? First thing is add pi everywhere. So I add pi here, here, and here. And that gives me pi is less than or equal to 2x, which is less than or equal to what? 3 pi. Now all I have to do is what? Divide everything by 2. So this tells me that one period is going to start at pi over 2 and it's going to end at 3 pi over 2. Now let's double check that to make sure it actually fixed everything for us. If I used my figure out the change in period, I would take 2 pi and divide it by b. What's 2 pi divided by 2? Pi. If I start at pi over 2 and I end at 3 pi over 2, have I gone pi units? So it takes care of that for us, as long as we take whatever the angle is, including the horizontal translation, sandwich it between 0 and 2 pi, and it will give us the starting point, the stopping point, and have the period fixed for us, okay? So one period is going to start at pi over 2, and then it's going to end at 3 pi over 2. I got to figure out what's in between, and then I'll get these other values. So talk to me about how I'm going to figure out this one.
Add them up, divide by 2.
Add them up, divide by 2. Can you do this one in your head? Pi over 2 plus 3 pi over 2 is 4 pi over 2, which is 2 pi. Divide that by 2 and you get, good job. Okay, now let's see if you can figure out what's in between pi over 2 and pi. Same process, add them up, divide by 2. So pi over 2 plus 2 pi over 2 is 3 pi over 2. If I multiply that times 1/2, what do I get? 3 pi over 4. Does that make sense? The other thing you could think of is if I were to figure out how far did I go to get from pi over 2 to pi, that was pi over 2 units. Half of that is pi over 4. So that would sort of make sense. If this is 2 pi over 4, if I add another pi over 4 to it, I'm at 3 pi over 4. I'm just kind of giving you another way you can think of it if you don't like adding them up, dividing by 2. Where will I be in between pi and 3 pi over 2? Say it again. Okay, I got to vote for 5 pi over 4. Do y'all agree? Yes? Yes. Because this would be 2 pi over 2 plus 3 pi over 2. And if I were to take 5 pi over 2 times 1/2, that indeed is 5 pi over 4. Now, that's everything I need to get one complete period. Notice this one is going to ask us to do 2. Now, we're going to get those in just a second. I'm going to say, let's go. I went ahead and I put some more tick marks on here. You could actually do them all on the positive end if you want, or you could go back this way. But we'll get one of them on here and then we'll extend it. What have I not marked off yet that I need to? amplitude, and the amplitude is 3/2. So I might want to mark off in units of 1/2. And now, if I were to graph this, cosine is, what do I need to think of? Hala. And since this starts at pi/2, I'm going to go ahead and put these values on here so I won't get confused in a minute when I start to mark these. And I know normally that means it starts at 1, goes to 0, goes to -1, 0, 1. But since my amplitude is 3/2, that means my high point's going to be where? 3/2. 3/2 times 0 is 0. 3/2 times -1 is a -3/2. 0 and a +3/2. So I'm going to do this and this to get one cycle on. And I'll go ahead and put that on to save a little time. So we're going to start here at 3/2 at pi/2. At 3 pi/4, we're at the axis. At pi, we're down at our low point, which is -3 pi/2. Back at the axis, up at the high point. Now, let's see if we can get the rest of this labeled so we can get 2 complete cycles. What did we figure out a minute ago is the difference between each of these marks. Like, if this is pi, which is 4 pi/4, and the next one is 5 pi/4, that's how much in each space? What do we have to add to pi to get to 5 pi/4? Do you follow what I'm saying?
Yeah, I know what you're saying. This one.
Okay, so yeah, in other words, if I were to take 5 pi/4 and subtract pi from it, and I know I need a common denominator of 4, so I got to multiply that by 4/4, that's a difference of how much? 5 pi minus 4 pi is 1 pi. Okay, so pi/4 is how much we had to add to get to the next unit if we had wanted to do it that way. I could also subtract pi/4 each time to get to another unit if I wanted. That would mean that this would be pi/4 here. We already know that's 0. What would this be? It would be a -pi/4, right? And then if I took away another pi/4, wouldn't that be a -pi/2? Okay, and then this would be a -3 pi/4. I mean, and you can use your calculator to help you if you want. I just have to make sure I keep the same scale. I keep the same equal units. Does that make sense? Okay. And I know something about this curve for the cosine. If this is a high point, what should this be?
Axis.
An axis. This should be what? A low point. Back to an axis, up to a high point. I would now have 2 periods on my graph. And if you wanted to make it all going out the positive direction, you could extend that, and you could just keep going this way. It doesn't make any difference where you put the 2 periods. You just have to be sure you show 2 complete periods. Good? Okay. You guys have put together quite a few. Here's the last transformation, and we're going to talk about vertical translations. If you have a vertical translation, bless you, look at what this equation looks like. You've got some constant that's added to whatever the function is. You know how we did the temperatures in Arizona and there was that +74 at the end? That was a vertical translation. It meant I took the sine curve, but I moved it up 74 units. So instead of the x-axis being sort of the midpoint going through the curve, y equals 74 is now the midpoint going through the curve. So this is going to tell us that we translate vertically when we just see a number that's added into at the end of the function, usually is where it shows up, could be at the beginning, but it's not in a parentheses, it's not just being applied to the x, it's being applied to the whole function. And it's exactly what you would expect when you see it. If I'm adding a number to it that's positive, which way am I going to move? If I'm adding I'm going to move up if it's a positive number. If c is greater than 0, and if it's a negative number, I will move down that many units. Okay, so let's see if we can roll this in with what we've already talked about and try to get this thing graphed over 2 periods. Now, tell me what transformations you see when you look at this. You said amplitude. What's my change in amplitude? My change in amplitude is 3. Okay, what else do you see? There's a change in period. What is it that's telling me I've got a change in period? The 2 right here. What else do you see? Good. The vertical translation tells me this thing is shifting 2 units. It's actually going to shift 2 units which way? This is going to go down, right? And I don't know why they put a graph on here that has all that going up, because we're going to need to move this thing down. So let's see, where do you want to start? I think you're onto something, Elizabeth. I would start with the vertical translation. Remember I said that however much this moves, it's like instead of being centered on the x-axis, it's now going to be centered on this y value. So if I move down to -2, you might want to put a dashed line there, because that may help us remember that's now going to be my axis value whenever I graph, okay? So we've taken care of that. My amplitude is 3. So I know I have to be able to move 3 units above and 3 below. So there's 1, 2, 3 units above puts me at +1. 1, 2, 3 units below puts me at -5. So we've marked that part off. Now what am I going to need to figure out? The period. I do have a change in period. In fact, now that we've taken care of those horizontal translations, if you like, you could do this and get your change in period that way as well, because all we're doing is what? Dividing by 2, which means this is going to go between 0 and pi. It's the same thing as 2 pi divided by 2, okay? So now that we've done that, you could just do this every time if you see you've got a change in period, and that would help you find everything. So tell me how we want to mark our x-axis. Remember, this is our ratio on the y. We've got to get our angles on the x. So if one complete period goes from 0 to pi, all right, what is halfway between 0 and pi?
1 pi over 2.
Very good, pi over 2. What would be halfway between 0 and pi over 2? Pi over 4, because pi over 2 times 1/2 would be pi over 4. This would be, if I add pi and pi over 2, that's going to be 3 pi over 2 times 1/2 is?
3 pi over 4.
Okay, now, question, do you guys want to go in the negative direction to get 2 periods, or do you want to keep going in the positive?
When we do the negative, all we do is add and mark the same thing with negative.
Very good. Since this didn't have any horizontal shift, it basically kind of reflects over the y-axis, doesn't it? So we could mark off and use the negatives of each of these. Negative pi over 4 negative pi over 2, negative 3 pi over 4, and negative pi. Okay. Who wants to come on down? I'm going to let you do this one. Next class, we will finish this last little bit that's in 6-4 so that we can kind of review all the transformations, have one more practice, and then we'll see what these things look like if we're using a cotangent, tangent, secant, or cosecant curves. But you've learned the transformations. Your quiz on Thursday is 6-1 through 6-3. Now, here's what that means. Will you see these translations that we covered today on the quiz? No, but will you see changes in period and amplitude? Yes, you will. And keep in mind some of the things we did before then, which involved giving exact values for things, using those formulas. That will be on the quiz too. Okay, so let me know if you have questions. You guys have a good day. I'll see you Thursday.